Hi, this is Nayan Kolar from Bengal College of Engineering and Technology, BCD department. Today we will perform experiment number 5. Today's experiment is design of a BCD to 7 segment decoder by using 7447 IC. 7447 is a BCD to 7 segment decoder. It takes BCD as input and convert it to 7 segment output. 7 segment output means it generates proper combinations of zeros and ones. If that zeros and ones is provided to a 7 segment display, it will generate our decimal number on that display properly. In this circuit, here is a BCD to 7 segment decoder, that is 7447 IC. We're using a common anode 7 segment display in this circuit. 7 segment display is connected to 5 volt supply with a resistance, through a resistance. So we use our resistance when we provide supply to this 7 segment display. Here in this IC, because it is a simulation and there is no provision to provide supply or ground, so that pin is not available here, so we don't show you the connections. 3, 5 and 4 is no connection, so we just leave all these pins as not connected. There are 4 input pins where we provide our BCD input, that is A0, A1, A2 and A3. The pin numbers are given here. Pin numbers are 7, 1, 2 and 6 respectively. The 7 segment are A, B, C, D, E, F and G. So these pin are connected to the proper pin with 7 segment display. So the pin numbers of the IC are given here. So the connection is very simple. So we just connect A to A, B to B, C to C and so on. All the connection, say the connections from input to the IC's input and the output to 7 segment display input are very simple and straightforward. When we start the simulation, so we provide 0 0 0 0 input, so we get 0 at 7 segment display. Now I just change my input to 0 0 0 and 1. So when we use 0 0 0 1 as BCD input, here we have 1. From the color combination of the wires, we can see that these 2 segments give 1 to this 7 segment display. So when we have 1 in this segment B and C, the corresponding 2 LED segments glow. So here we have B and C, these 2 LED glows and it forms a 1. At the same way, when we provide 1 0, that is 2, and it forms a combination of zeros and ones. That zeros and ones, when connected to the 7 segment properly, we get a formation of 2. In the same way, 1 1 forms 3, 1 0 0 forms 4, 1 0 1 forms 5, 1 1 0 forms 6, 1 1 1 forms 7, and here 1 triple 0, that is 1 0 0 0 forms 8. So to test our 7 segment is okay or not, we can just connect the LED or 7 segment display with our IC and give input 8 or set input 8 so that we can see a 8 formation. If it gives 8, which means all the LED segments are proper, which means all the LED segments are glowing. So we can check by 8 as input. Now after 8, 1 0 0 1 forms a 9. So up to here it's a 4-bit BCD. So BCD to 7 segment decoder using 7447 circuit simulation works properly. Thank you. Last time I have shown you the circuit simulation of a BCD to 7 segment decoder circuit. Here I will explain you how to build the same circuit step by step on a breadboard system. Here you can see this is the circuit diagram of our BCD to 7 segment decoder circuit. Here we have used IC7447 as our BCD to 7 segment decoder. The BCD inputs are A0, A1, A2 and A3. The corresponding pin numbers are 7, 1, 2 and 6. Pin number 16 is VCC and pin number 8 is ground. The output pins are A, B, C, D, E, F and G that produce the combination of zeros and ones that is required to generate the decimal output by using 7 segment display. The corresponding pin numbers, you can see that. In the 7 segment display side, the corresponding pin numbers from segment A to segment G as given here, which is 7, 6, 4, 2, 1, 9 and 10 respectively. Pin number 3 or pin number 8 can be used as VCC or provide supply to this 7 segment LED. Now we always use a resistor to provide VCC to the 7 segment, otherwise it will damage. Now remember, when we are using common anode 7 segment display, we provide VCC. In case of when we are using common cathode 7 segment display, instead of providing VCC to the 7 segment display, we provide ground on pin number either 3 or 8. This is the exact circuit diagram if we are using IC7447 as a VCC to 7 segment decoder and a 7 segment display with common anode. But for a change in our circuit, we are using CD4511, which is also a BCD to 7 segment decoder with same pin configuration, but it is used with common cathode 7 segment display. So instead of using a common anode 7 segment decoder, we are using a common cathode 7 segment decoder in this breadboard system. However, in both cases the pin numbers and circuit connections are same. So there will be a very small difference in connection of the circuits, but most of the cases or most of the connections are same between these two circuits. Say all the input connection pins are same, all these segment connections pins are same, only we just connect ground from pin number 3 instead of connecting it to VCC in case of common cathode, and In case of 7447, this 3, 4 and 5 remains no connection. Here we have a small connection in 3, 4 and 5. That's the basic difference. Otherwise, all the connections are same, that is shown in the circuit and this breadboard system. So I am explaining you one by one. So this is our, say, 4511 IC. At pin number 16 we provide BCC. At pin number 7 we provide ground. After that we provide one by one connection to the segments. So from the beginning, at pin number 13 we have A, output A. So 13 is connected to 7 of 7 segment display. So here you can see the pin number 13. Now how we connect pin number 13? So here is a notch, and just below the notch there is a white dot, and the nearest pin to the white dot is pin number 1. Now from here we just start counting. So 1, 2, 3, 4, 5, 6, 7 and 8. Then 9, 10, 11, 12, 13. So 13, which means this. This wire actually connected to pin number 7 of 7 segment display. Now how we know this is pin number 7? So in 7 segment display also we just start counting our first pin from here. So left bottom pin is 1, then 2, then 3, then 4, then 5, and at the top side or upper side 6, 7, 8, 9, 10. So pin number 7 is this. So we can understand that the first connection is pin number 13 to pin number 7. So pin number 13 is connected to pin number 7. Then pin number 12 to 6. So pin number 12 to 6 is his, and then 11 to 4. So we know 11 to 4. So this is 11 to 4. So we know this pin is 11, and here this is 4. Then 10 to 2. So this is 10 and it is connected to pin number 2 of 7 segment display. Then 9 to 1. So we can see that pin number 9 is connected to pin number 1. And then 15 to 9. So 15 is here. So this wire is connected to pin number 9 of 7 segment display. So this pin is pin number 15 of 4511 decoder or the decoder IC, and it is connected to, say, pin number 9 of the 7 segment display. Then pin number 14 to 10 of the 7 segment display. So pin number 14 is just before the pin number 15. So from here to here. So this pin is 10 of 7 segment display. So as you can see, I have arranged the wire so that the each and every connection is displayed in a very neat and clean manner. So when we connect in our actual lab environment, or we just implement this circuit on the breadboard inside our lab, so just when you look at this circuit, so you can maintain the sequence. So we can use this wire first, then this wire, then this wire, then this wire, and so that. So in this way, if we connect like this, your circuit will look a little bit clean, so that if we have any error in our circuit, it can be detected easily. In the case if we actually using a 4511 IC with a common cathode 7 segment display, we have to do these connections. So pin number 3 and 4 we have to short it and connect it to VCC. So we have provide VCC at pin number 3 and 4, and we have to connect pin number 5 to ground. So there's a very small connection, which is 3 and 4 should be connected to VCC and pin number 5 should be connected to ground. If you are using a 7447 IC, so we just leave these 3 pin as no connection. If we provide the inputs, our circuit will be completed. So we have a 4 inputs here. Just connect one by one input to the proper pin. So A0 is connected to pin number 7. So A0, in this case here we are using A0, A1, A2 and A3. Always remember the most significant bit we set at left side. So A3 comes at leftmost side. A0 we connect it to pin number 7. Then A1 is connected to pin number 1. As you can see, it is connected to pin number 1. And then A2 is connected to pin number 2. So you can see it is connected to pin number 2. And A3 is connected to pin number 6. So here also I have connect the wires or shown the wires so that it is visible properly, so we can see the wires are not overlapped to each other, so that our understanding to the circuit is proper. So if you look at the circuit, you can see that the positioning of each and every wire, how we connect, because it's a simple connection and a very straightforward connection, so there is not much scope of explanation. So we just start our simulation so that we can understand this circuit is working properly or not. So when we start our simulation, just first start with 0 0 0 and 0. So here we have 0 0 0 0 input, and that is gives you output 0. So here we can see that these segments have glown, so which means A, B, C, D, E and F segments have glown. That forms a 0, which means the combination of the required zeros and ones provided to this 7 segment display, which glows these segments, and that forms a 0 shape. By the same way, we just change the inputs. Now one by one we change our inputs. So at 0 0 0 0 we get 0, at 0 0 0 1 we have 1, at 0 0 1 0 we have 2, 0 0 1 1 we have 3, then 0 1 0 0 we have 4, 0 1 0 1 we have 5, 0 1 1 0 it forms 6, 0 1 1 1 it forms 7, and 1 0 0 0 it forms 8, and 1 0 0 1 it forms 9. So circuit is working very properly and our simulation is successful. If you build this circuit in a lab environment, it will give you the same output with the same connections. Now the last thing, as I have said earlier, if you want to check your 7 segment is proper or not, say all the segments are glowing properly or not, we just connect the circuit and provide 8 as input. If you get a proper 8 formation, which means all the LED segments are proper. If it is not gives the full output, or it is not providing you output 8, which means either circuit connections are not okay, or there is the possibility that any of these segments may damage. So this is a real life scenario where we can check our 7 segment decoder. In the case where a particular segment is not glowing in any of the inputs, any of input, that means that segment of the 7 segment LED or 7 segment display is not working properly, or it may be damaged. So remember this, and we can see that our circuit is working properly. So the experiment of BCD to 7 segment decoder is successful. Thank you for watching.